Hey everyone, today we will discuss about this problem statement. This is we call as two sum. The problem statement states that given an array of integers and an integer target, return indices of the two numbers such that they add up to a target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So if we just look at the problem statement, what we know is that there is, it says you may assume that each input would have exactly one solution, right? So basically there will be only one solution, and you may not use the same element twice, so we cannot reuse the same element. Okay, so these are the two things that we know from the problem statement. Now let's think of how we can solve this problem. So the very first solution which comes to our mind is that we can check for every pair of numbers in the array, and whoever the sum matches the target, that will be our answer, right? So that will be our first solution, and this will be a brute force solution for this one. Let's just write the code for that now. So it will be private int to sum. I'll name it as solution 1, and it will take two inputs, number and target, and it will return an integer array. Okay, what will be the code for it? For int I equals to 0, I less than nums dot length I plus plus. For int j equals to 0, oh not 0, j less equals to I plus 1, j less than nums dot length j plus plus. So we are just using two pointers, and if my nums of I plus nums of j double equals to target, I'll just have to return it. So I'll return the new int I comma j. That's it. And if we didn't find any, I'll just return null. Alright, so if I have to call this, then it will be to sum 1. I'll pass this nums and target. I'll get the answer, and I'll just print out the answer. System.out.println answer of 0 plus answer of 1. Alright, let's try to run this function. Java to sum.java, and it has given 0, 1, which is the expected answer.
Now, if we analyze the time complexity for this solution, since we have two nested loops and the maximum a loop can go, the outer loop will traverse for total length of the array. If the length of the array is n, traverse for n times, and if inner loop is of n, then it will also traverse n times. So our time complexity for this solution is O of n to the power 2, O of n square, which is not the best solution for this problem. So now let's think of another approach that what if we sort this array and then take two pointers and check the combination, basically the sum of the numbers at two pointers, if they match up to the target.
So how the two pointer will work? Let's suppose this is our array. We'll take the same example: 2, 7, 11, and 5. Now if we just sort this array, it will become 2, 5, 7, 11. And now let's take two pointer, like we'll start the first pointer at the first index and the second pointer at last index. Now we'll take the sum of these two numbers, 2 and 11, which will come out to be 13, which is not equal to the target number of 9. and it is greater than the target number, so we have to take a combination whose sum is less than 30. Now since the array is sorted, we know that if we move the rightmost pointer towards left, and the left number to this pointer is smaller than this one, the current element, so our sum will be smaller. So now the 2 and 7, 2 plus 7 will be 9, which is equal to our target. So these two are our answers. But if you notice that in the problem statement we have to return the indices of the numbers, and if we sort this element the indices will change, so we cannot use this approach. Alright, now let's think of another approach. What if we store the diff of current number, basically the target, minus nums of I, if I store it somewhere, and if I check that at every element this diff is present, we know that there is a possible solution, and we can return the answer for that. I will just code the solution for that. We'll name it as 2 and nums comma in target map integer comma integer. The value we will take to store the index of that number, and I equals to 0 less than nums dot length I plus plus, and diff equals to target minus nums of I. If my data dot contains key diff, then I'll just return new int I comma data dot get diff. If it is not, I'll just put it nums of I comma I and return null. That's it. I'll just change it here. Now we'll run the function. Okay, I'll have to import the class. Okay, so we have imported the class. Now I'll just run the function again, and see, we have got 1 comma 0. So this solution seems to be working. Okay, now we analyze the time complexity of this solution. So we are using a map which will take O of n space maximum. We are storing all the elements, and we are taking a loop which is iterating from the first to the last, which is again an O of n. So we have O of n is the time complexity, and O of n is the space complexity. Now this is a better solution. I'll tell you why. Because with time our hardwares have improved and the cost of hardware has gone down, but the time is something that is always have been limited, and in this solution it takes O of n time, which is much better than O of n square. So this is a better solution. If you like the video, please do like and subscribe to the channel for more such videos, and I have also added my blog link where you can also find the written solution for this explanation to this problem. Thank you.